Hello friends, I am going to make a video of these notes because this is a topic that I don't think everybody's going to feel super confident about, and I want to make sure that you have time to process this because our classes are big, so they're loud. Sometimes you're starving if you're in fourth hour. So let me just buzz through this. First of all, piecewise means exactly that. It's in pieces. But don't make this harder than it is. A piecewise function simply means that you have more than one function, or I would say more than one rule. Okay, what does that mean? So this part will always kind of tell you your categories. And it's always going to split your graph. So since this is happening at 2, 2 is my key number, there's a rule for x's that are less than 2, and there's a separate rule for those that are greater than or equal to 2. So what I like to do if I'm forced to draw these is I make myself a little dashed line here at x equals 2. Keeping in mind that the top graph is going to have an open circle because that's the less than, strictly less than, and the bottom's greater than or equal to. So that's going to be my included piece. So depending on the category, you use a different rule. So let's take a look at the top. The top is a parabola. And by this point in your life, you kind of have to have an idea of what that's going to look like. So what I always do, if you need to plot points, plot points. And if you are looking at less than 2, that's going to be this rule. And then on the other side of the line, the negative 2x plus 3 rule will apply. So you write down as much as you need to in order to make it make sense to you and be successful. So in terms of this x squared plus 1, I'm going to always pick the breaking point, which is the 2, but keeping in mind that's an open circle. And then I need x's that are less than that. So I would use like 1, 0, negative 1, that kind of thing. So when I plug those in to the rule, which is x squared plus 1, then I'm going to get my set of y values by plugging those numbers in. So you should already know it's a parabola. So at 2, it's 1, 2, 3, 4, 5, but it's an open circle. At 1, it's 2, and so on. And I already know it's a parabola, and so it's going to look like that. That is my first piece to the graph, therefore the name, piecewise graph. My other piece is going to be for those that are greater than or equal to negative 2. And so that's going to be over on the right. And again, I have to pick appropriate numbers. Negative 2x plus 3 is a line, so I don't really need a bunch of points. So I'm going to go ahead and always pick the break-even point. This one is the or equals to section. So that means that'll get a solid dot. And then you have to pick at least one number to the right. So pick 3. If you really like having more numbers, pick 4 as well. So here the rule is negative 2x plus 3. The rule generates your y's or your f of x's. So these are the numbers that I get when I plug those in. So at 2, I'm at negative 1 with my filled in circle. And at 3, I'm down 3 and then down to 5. And that's a straight line. Now, keeping in mind right here at my blue break-even spot, see how this has an open circle and then this has a closed? That's why it still passes the vertical line test. So that's a piecewise graph. You have to be able to graph the pieces. But each piece is an Algebra 1 topic that we again practiced in Algebra 2. Here's where it gets tricky. Here's where pre-calculus comes in. Domain is going to be from left to right, but you also have to use your big brain. Let's refresh our memories that this is the new way of saying open circle not included. This is the new way of saying closed circle included. And you can't include infinity because you can never get there. So keep in mind that plus and minus infinity is going to fall into this parentheses camp. So the domain is going to be farthest left that this goes. Well, looking at the left end of my graph, even though it's going up, it's also going out slowly but surely. And then I follow it along, and even though it stops here, it picks up at that same number 2 and keeps on going to the right forever because of that arrow. And yes, I get that it's pointing downward, but it's also going out slowly but surely. So the domain in this case is all reals. And we would write that as saying, I will go from negative infinity on the left to positive infinity on the right. I use parentheses rather than brackets because I never really get there. Range is my y's, and that's going to go from the very bottom all the way up to the top. But if you have a region where this graph doesn't actually have values, you have to be careful about that. And we do have that. Like in here, there's a break. The graph goes to here, and then it picks up again here. So since we have two pieces from top to bottom with a space in between, you have to have two pieces when you go to write your range. So the lowest piece is this green one, and it points down forever, so it goes down to negative infinity, which you can't include, and it goes up to right here. And right here is at -1 for a y value. Then you unite it or put it together with the next piece. I don't care if you use the union circle or not, but then it starts here again, which is at +1, and that lowest point of the parabola actually hits 1. And then even though this one stops, this side goes up forever, so this will go to infinity, which I can never get to, so parenthesis. All of these problems are just asking me to find values, keeping in mind that this is like saying, hey, -2 is your x, what is your y? So go to your graph and see. I'm going to actually clear my graph out because it's so messy. Oh, actually I can't because I drew it, so then it'll all disappear and then I'll be sad. Okay, so this is saying at -2. So at -2, what's your value? Well, 1, 2, 3, 4, 5. We already did that one. Actually, I guess we didn't, but that's going to be a 5. When your x is 2, what is the y? That's what that next part is asking. So at +2, the value is here at -1, and so on. So this is saying when your value is 4, where is your number? And it's at 1, 2, 3, 4. Excuse me, 1, 2, 3, 4. It's down 5. And at -10, so I can't see it on my graph, but I do know that -10 is less than 2. So I go back up here and I take a look at my graph, excuse me, my options. I'd be plugging it in here. So I'd have -10 squared plus 1. And 0, I can either look at the graph if I trust my graph, or I can look up here and say 0 is less than 2. So 0 squared plus 1. And then down here, you're simply going to do the exact opposite thing. How many pieces do you have? 3. There's this piece. There is this piece. And then there is this piece. Each piece gets a different rule. Each rule needs a category. So if I use my big brain, I'm going to go ahead and have my 3 categories, my 3 rules, and that makes up my piecewise function. My first category goes to here. Now, one thing that I can't tell from this graph, and so I obviously can't, say right or wrong, is which of these is the circle and which of these is filled in. So for funsies, we're going to pretend that the blue line is the one that's filled in. So the first category for my x's is going to be that the green line goes from -infinity until I hit -2 for an x. So that rule holds for x's less than -2. How about the blue rule? This is saying where. Where is this rule holding and what does it do? So the next section, this blue section, is true from -2 to +2. And I just decided that we were going to call that the included part. So I would have x in between 2 and -2. And then my pink part is from here on. So that would be called x is greater than +2. So that's the where, the interval on when that or where that rule holds. The what is, what's the equation? Well, these are all linear. So this goes back to your knowledge or understanding of how to write the equation of a line. did it in Algebra 2, did it in Algebra 1, and so by now it's supposed to be a skill that you're fairly comfortable with. To me, the easiest one is the blue piece because it's horizontal. And horizontal lines are just y equals, and all you put in here is the actual rule. You don't write y equals for each of them because that's what this part is representing. And it goes straight across at 1, 2, 3, 4. Of course, I drew all over it, so I can't really see, but it's at 4. So my equation would be y equals 4, horizontal line, only crosses y at 4. So that's what I write. How about the green piece? The green piece goes, and you can do this a couple different ways. You can use actual points, you can count, whatever you're comfortable with. If I start here, I go up 1, 2, 3, over 1, up 1, 2, 3, over 1, and so on. So I know my slope is 3. And then you can use any of the things we've been practicing. You can use your slope being 3, and then you can use any point that goes through. So like one of the points that it goes through is negative 1, 2, 3, 1. And then I can do y minus y1 equals m times x minus x1. And I'm going to do my work because I got to get my equation. And so I'm distributing my 3. So again, this just keeps going back now to like, okay, well, you're supposed to know this because we've practiced it and you've done it throughout the years. So let's go ahead and apply that. Well, I'm stuck. I did something stupid. Up 3 over 1, up 3 over 1, up 3 over 1. It should cross the y-axis at a really big number. Oh, that's why, because this point's negative 3, so that's a plus, that's a plus, that's a plus. Okay, plus 8. Okay, how about pink? So you have to do like I just did. I got my answer. I'm like, common sense, that doesn't make sense. This is the y-intercept. It's going to cross the y-axis at a big positive number if I extend that green line up this direction. It's not going to cross at a negative number, so it helps me catch silly, dumb mistakes. Okie dokie, same kind of concept over here on the right. It's not like super complicated math. It's just a lot of problems all in one because you have 3 pieces, so 3 equations, so 3 problems to solve. So I'm looking over at the pink one now, and I'm counting my slope however I want. Down 3 over 1, it looks like. Down 3 over 1. I can't see very well because I drew on the lines. So let me double check. So if I start here, down 1, 2, 3, over 1. Down 1, 2, 3, over 1. That looks good. So here I'm going to have a slope of negative 3. And what's a point that it crosses through? Well, I'm trying to find a good one. This one looks like a nice easy one. That's at 1, 2, 3, 4, down 2. So y minus y1, so that turns to plus m times x minus x1. And then you do the same thing every time. Distribute and move this over. So now I have my rule, negative 3x plus 10. Okie dokie. Oh, see, now I did 2 dumb mistakes. Because now that I think about that, see, I just refused to start this video over. So sorry, folks. Looking back here, I changed that to a positive. So when I add the 1 over, this should have been a 10. No big deal. Same concept. So what's the difference? These two are both going to cross at 10 if I extended them up here, but this one was a positive because it's going up from left to right, and the pink one is negative because it's going down from left to right. So, you got to use your big brain, right? Like I'm a math teacher and I know what I'm doing, but I make mistakes because I'm trying to hurry and there's a lot to manage. So use your common sense and be like, well, wait a minute, that doesn't make sense. And then double check it and you can catch all your silly mistakes like I did. So at negative 2, where is my value? And then I'm just going to go through and use my graph to say, oh, that's at 4. That's at 4. and then I'm just looking for the y value that goes with each of these x's. And if it's not on the graph, like this -10, I find the category where it belongs, which would be this top one, and I plug it in to the rule that goes with that category to get my answer. All right, that is piecewise. So wrap your big fat brain around that and be better than me. Don't make mistakes. See ya.